What about exercise for slowing cellular aging? Stress management help, but we can't always change our station in life, but we can always go out for a walk. Researchers studied 2,400 twins, and those that exercised more pumped up their telomeres along with their muscles. These were mostly folks in their 40s. Does it still work in our 50s? Yes, those habitual exercisers were working out 3 hours a week better than the younger group. The heavy exercise group here was only averaging a half an hour a day. What happens if you study hardcore athletes? Here's the telomere lengths of young, healthy, regular folks at around age 20, and then age 50, which is what you'd expect. Our telomeres get eaten away as we age, but what about the athletes? They started out in the same boat, nice, long, young, healthy telomeres capping all their chromosomes, and then at age 50, they appear to still have the chromosomes of a 20-year-old. But these were marathon runners, triathletes, running 50 miles a week for 35 years. That's worse than the meditation retreat study. And it doesn't help us with the original question. What was it about the Ornish intervention that so powerfully protected telomeres after just 3 months? We saw that just stress management seemed to help, but what about the diet versus exercise? Was it the plant-based diet? Was it the walking 30 minutes a day? Or was it just because of the weight loss? In those 3 months, participants lost about 20 pounds. Maybe our telomeres are happy if we lose 20 pounds using any method, starting a cocaine habit, getting tuberculosis, whatever. To answer this critical question, was it the plant-based diet specifically, the exercise, or the weight loss? Ideally, you do a study where you randomize people into at least 3 groups, a control group that did nothing, sedentary with a typical diet, a group that just exercised, and a group that lost weight eating pretty much the same diet, but just in smaller portions. And I'm happy to report in 2013, just such a study was published. They took 400 women and randomized them into 4 groups, a portion-controlled diet group, an exercise group, and a portion-controlled diet and exercise group for a full year. And here they are. This is how long the telomeres were at baseline. After a year of doing nothing, there was essentially no change in the control group, which is what we'd expect. The exercise group was no wimpy, Ornish 30-minute stroll, but 45 minutes, moderate to vigorous exercise like jogging. After a year of that, how did they do? They did no better. What about just the weight loss? Nothing. And exercise and weight loss, no significant change either. So as long as we're eating the same lousy diet, it doesn't appear to matter how small our portions are, or how much weight we lose, or how hard we exercise. After a year, they saw no benefit. Whereas the Ornish group on the plant-based diet lost the same amount of weight after just 3 months, exercising less than half as hard, and saw significant telomere protection. So it wasn't the weight loss, it wasn't the exercise, it was the food. What about a plant-based diet is so protective? Higher consumption of vegetables, less butter and more fruit. And from the latest review, foods high in fiber and vitamins. But the key may be avoiding saturated fat. Swapping just 1% of saturated fat calories in a diet for anything else can add nearly a whole year of aging's worth of length onto our telomeres. Researchers have calculated how much our telomeres we may shave off per serving of foods like ham or hot dogs, bologna, salami, or other lunch meats. Fish consumption was also significantly associated with shortened telomeres. Saturated fats like palmitic acid, the primary saturated fat in salmon and found in meat, eggs, and dairy in general, can actually be toxic to cells. This has been demonstrated in heart cells, bone marrow cells, pancreatic cells, brain cells. And the toxic effects on cell death rates happen right around what you see in the bloodstream of people who eat a lot of animal products. It may not be the saturated fat itself, though saturated fat may just be a marker for the increased oxidative stress and inflammation associated with animal-derived foods. With this link to saturated fat, no wonder lifelong low cholesterol levels has been related to longer telomeres and a smaller proportion of short telomeres. In other words, markers of slower biological aging with lower cholesterol. In fact, there's a rare congenital birth defect called progeria syndrome, where children essentially age 8 to 10 times faster than normal, and it seems associated with a particular inability to handle animal fats. In this case report, they started trying to lower her cholesterol starting at age 2, but sadly she died shortly after this picture was taken at age 10. The good news is that even if we've been beating up on our telomeres, despite past accumulated injury leading to shorter telomere length, current healthy behaviors may help to decrease our risk of some of the potential consequences like heart disease. Eating more fruits and vegetables and less meat, having more support from friends and families to attenuate the association between shorter telomeres and the ravages of aging. To summarize, here's a schematic of this constant battle. Inflammation, oxidation, damage, and dysfunction, constantly hacking away at our telomeres. At the same time, our antioxidant defenses, a healthy diet, exercise, stress reduction are constantly rebuilding them. Telomere length shortens with age. Progressive shortening of our telomeres leads to cell death or transformation into cancer, affecting the health and lifespan of an individual, but the rate at which telomere shortening can be either increased or decreased by specific lifestyle factors. Better choice of diet and activities has great potential to reduce the rate of telomere shortening, or at least prevent excessive telomere shrinkage, leading to delayed onset of age-related diseases and increased lifespan.